Hello everyone and welcome. In this lesson, we're going to be learning about oxidation number, how to define it, how to determine it and calculate for it in a substance. Now, what is oxidation number? The oxidation number or state of a substance is determined by the number of electrons it lost or gained during the process of a chemical reaction. Now, a substance undergoes chemical reaction, there's usually a transfer of electrons. It's either the substance is gaining electron or losing electron. At the end of the reaction, the oxidation number of that substance is going to be the number of electrons it has lost or gained. Now, when the substance loses or gains electron, it possesses an electric charged particle. Now, the electric charge of that substance is what determines the oxidation number of that substance. Now, I'm going to show you a periodic table that shows oxidation number of all the substances as you have it here. Now, these are all elements in group 1. These are all elements in group 2, group 3, 4, 5, 6, 7, and here you have halogens. At the middle of group 2 and group 3, you have the D block elements. Now, the oxidation number of all these substances, let's begin with the group 1 element here, is going to be the number of electrons they lost or gained. Now, group 1 elements have one valence electron, for instance hydrogen and lithium and sodium. If they undergo a chemical reaction, they tend to lose their electrons because they are metals. Now, when they lose their electrons, they have an oxidation number of +1 because they just lost one electron. What about the group 2 elements? Group 2 elements in a chemical reaction usually have 2 valence electrons. At the end of the reaction, when they undergo this reaction, they lose 2 electrons. That's why they are going to have +2. The group 3 elements have 3 valence electrons. They usually have +3. While here, group 4 elements have 4 valence electrons. They usually lose all 4, which is usually difficult, so they undergo your covalent bond, and in this covalent bond they usually donate or contribute 4 electrons. That's why they are going to have 4 or +4 as their oxidation number. Now, take note, the reason why they have positive signs as the oxidation number is because metals have positive signs when they lose, or metals have positive signs when they lose electrons. What about the non-metals? The non-metals here, beginning with the elements in group 5, usually gain electron in the chemical reaction. Now, the number of electrons they gain will be their oxidation number. Because they are non-metals, they usually have negative signs. Nitrogen, for instance, has 5 valence electrons. It's going to gain 3 to become stable, or as it undergoes chemical reaction. That is why it's going to have -3. Oxygen too, the same thing with sulfur. Then all the halogens, they gain 1 electron. That's why they are having -1. Now, the group to the far right is group 8. That's the noble gases. They do not undergo chemical reaction in the sense that they do not lose or gain electrons. They are stable. They are electrically stable. Now, these do not have any oxidation number at all. Now, there are some substances here that have more than one oxidation number. For instance, carbon. In fact, most of the elements in group 2, in group 4, for instance, you have carbon and tin and silicon, and what you have here to be lead. They have the ability to have 2 oxidation number of +2 and +3 and +4. While nitrogen here also has the ability of existing in more than one oxidation state of -3 and -5, as the case may be. They will also talk about the D block elements. D block elements have electrons in their 4s block and their 3d block. Now, they have the ability of exhibiting what you call variable oxidation state. For instance, we have here that iron can exist in the oxidation state of +2, +3, even +4. Manganese can exist in the oxidation state of +2, +3, and +4 as well. Copper has the ability of existing in more than one oxidation state of +1 and +2. Now let's see some of the rules that we have to employ when we are calculating oxidation number of substances in a chemical reaction. Rules of oxidation number. Rule number 1 is that if an element undergoes the chemical reactions in a chemical reaction, the oxidation state of the free element when it is uncombined is 0. So oxidation number of magnesium is 0 if it is free and uncombined, and the oxidation number of chlorine gas is 0 if it is free and uncombined to any other element. Rule number 2 is this, that the oxidation number of an ion, whether it's a simple ion or a complex ion, is always equal to the sign and the size of the charge the ion possesses. For instance, this is sodium ion. It has a charge of +1. Therefore, the oxidation number of sodium ion is going to be +1. This is a charge called sulfide ion, both of them being simple ions. It has an oxidation number of -2. Therefore, it has a charge of -2. Therefore, the oxidation number is going to be -2. Here you also have a complex ion known as ammonium ion with an oxidation number of +1. The oxidation number is going to be as a result of the sign and the charge size of the ion. Now the third rule of oxidation number is that if it is a compound, the oxidation number is going to be the sum of the oxidation number of all the elements in the compound. And when you do the sum, you find out that it's equals to 0. Therefore, the oxidation number of a compound or a molecule is usually equals to 0. Take for instance, these are examples of molecules or compound. This is carbon 4 oxide. Carbon 4 oxide is a molecule. The oxidation number is equals to what? 0. H2SO4, that is tetrasulfate 6 acid, is also a compound as well. The oxidation number is equals to 0. And you also have the same thing for sodium chloride. Now, if you were to calculate the oxidation number of all the elements in carbon 4 oxide, which is carbon and oxygen, and add them, take a sum of it, is going to be equals to 0. The same thing applies to tetrasulfate 6 acid and sodium chloride. If you take the oxidation number of sodium and the oxidation number of chlorine and add them together, you are going to get 0. Now, there are exceptions to these rules, and the exceptions are these. In terms of the oxidation number of oxygen, that the oxidation number of oxygen is always -2, except in peroxides where it is -1, and the oxidation number of hydrogen is always +1. Remember, hydrogen is a group 1 element, except in a group of substances we call hydrides where it is -1. Now let's do some calculations on oxidation number. Example 1. You are asked here to calculate the oxidation number of carbon in H2CO3. Now remember our second rule rather, that the oxidation number of a compound is always equals to 0. So we are going to say the oxidation number of H2CO3 is equals to 0. That's rule number 3. Now, because we are interested in carbon here, we are going to say let the oxidation number of carbon be any letter we choose. In this case, let it be A. Now remember that the third rule says that the oxidation number of all the elements in a compound, when we take the sum, it is going to be equals to 0. So if I say 2, that's the oxidation number of hydrogen, plus 1, which is the number of atoms of carbon, that's the number of carbon, then how many oxygen do we have here? We have 3. 3 times the number of oxygen. When we take the sum, we are going to have it to be equals to 0. That's what we have here. Now, the oxidation number of hydrogen, like I said earlier, is always +1, except in peroxide. So we are going to have 2 times the oxidation number of hydrogen, which is +1. We have earlier said let the oxidation number of carbon be A. So I'm going to say 1, which is the number of atoms of carbon, times A. Then we have 3 oxygen here, so we're going to say 3 times the oxidation number of oxygen. Remember that the oxidation number of oxygen is -2, except in peroxides where it is -1. Now the sum of all this is going to be equals to 0. With our mass, we are going to have that 2 multiplied +1 is going to give us +2. 1 times A is going to give us A. while 3 times minus 2 will give us minus 6. We are going to have here that A is going to be equals to minus 6, is going to be equals to 6 minus 2, and that is going to give us plus 4. Hence, the reduction number of carbon in H2CO3 is going to be equals to 4. Now, one of the uses of oxidation number is that it helps us to name a compound. So we are going to use the answer we got to name this compound by determining to name the compound. Then we're going to have, hence the oxidation number of the compound is going to be trioxo, because you have 3 oxygen carbonate. Now the oxidation number of carbon in this compound is 4. That's why we're going to have carbonate 4. Now let's calculate the oxidation. Let's see another example. Calculate the oxidation number of chromium in K2CrO2O7. Now the substance we are giving here is a compound, so the oxidation number of the compound is equals to 0. Now we are interested in chromium, so let's say the oxidation number of chromium be S. Now we have 2 atoms of potassium here, 2 atoms of chromium, and 7 atoms of oxygen. So we are going to say 2 times the oxidation number of potassium plus 2 times the oxidation number of chromium plus 7 the number of atoms of oxygen times the oxidation number of oxygen. Everything equals to 0. Now the oxidation number of potassium is going to be plus 1 because potassium is a group 1 element. That will mean 2 times plus 1 plus 2 times X, which is the oxidation number of chromium that we earlier stated here, plus 7 times minus 2, which is the oxidation number of oxygen, equals to 0. When you do your mass, you are going to find out that 2S is going to be equal to plus 12. Now that is going to give us plus 6 when you make S your separate formula. So therefore the oxidation number of chromium in K2CrO2O7 is plus 6. Therefore the compound is going to be named as potassium hexaoxocarbonate 6. Let's see another example 3. We are asked here to calculate the oxidation number of manganese in MnO4 minus. Now this one is not a free element, it's not a compound, it is an ion. And we said, according to rule number 2, that the oxidation number of an ion is going to be the sign and the size of the ion. Hence it's going to be minus 1 because we have 1 negative charge here. Now how many atoms of manganese do we have? 1. How many atoms of oxygen do we have? 4. Now let's begin by saying the oxidation number of manganese be any letter we choose. In this case, let's choose Y. Now this is going to be equals to 1 number of manganese atom times the oxidation number of manganese times plus 4 times the number of oxygen atom times the oxidation number of oxygen. Everything equals to minus 1. Now when we substitute, we are going to have 1 times Y plus 4 times minus 2, which is the oxidation number of oxygen. Everything equals to what? Minus 1. Now when you carry out your simple arithmetics here, you are going to have that Y is going to be equals to plus 7. Now the oxidation number of manganese in MnO4 is going to be plus 7. Hence the name of the compound is going to be tetraoxo, that is for 4 oxygen, manganese 7